Hello, welcome to the first episode of Tronics in 10. My name is Brian, and I'm going to share my knowledge with you on building electronic devices. We're going to use off-the-shelf parts, and I'll show you how to build different things and help you learn more about electronics. Before we can build any circuits, we must first build a circuit board, which will be the foundation for our circuit. And it all starts with a piece of copper-clad circuit board. So, let's get started. To begin our circuit board construction, we're going to start out with a piece of copper-clad circuit board. And you're going to want to cut some narrow strips from the same material. The strips will look like this, and we're going to use these strips to distribute the DC operating voltage for our various stages used in our project. We're going to take the strips and mount them on top of the board, such as this. And we'll be soldering bypass capacitors from the strip to ground to ensure that the DC voltage remains clean and does not have any signal artifacts riding on the DC distribution bus. Now, to show this better, I have laid out strips across the circuit board. Here on the side is where our DC operating voltage will enter. These leads will connect to either a 9-volt battery or a bench power supply. And I have one strip here for one stage, and then I have another strip here for another stage, and another strip here that I put down for the first stage. Now I'm going to zoom in, and you'll be able to get a closer look at the bypass capacitors. We'll start on the end where the power comes in. I have two different types of bypass capacitors. I have a 1 mic electrolytic cap, which takes care of the lower frequency components that may be riding on our distribution bus. And then I have a smaller cap, which is 0.01 microfarad. That takes care of the higher frequency components that we don't want riding on the DC bus. And then I have here another strip, but you will notice in the middle that I have a resistor. This is a low value resistor. It is 22 ohms, and the color code is red, red, black. And this resistor, working along with the 0.02 microfarad disc caps that I have on either side, that forms a decoupling network. And a decoupling network helps to isolate the stage on this side from the stage on this side. And as I go further down the line, I have another electrolytic capacitor, and I have another decoupling resistor, 22 ohms, that isolates this stage from this stage. And I also have another electrolytic cap on this distribution bus, as well as a 0.02 microfarad cap, and then at the very end I selected a 0.1 microfarad cap. The one end of the cap goes to the ground foil, the main ground plane of the circuit board, and then in the case of electrolytic caps, the positive lead of that cap will connect to the distribution bus. So doing this ensures that we have a nice clean DC voltage bus to distribute among our stages. Now obviously if your circuit only has 1 or 2 stages, you're not going to need something quite this elaborate. You may only need 1 strip to distribute your voltage, and your circuit board may only be a fraction of what you see here. But this is necessary when you build electronic projects, that you keep your DC distribution bus clean, because it is a frequent path in which a signal can take and create feedback problems. Let's say we have an audio amplifier here, a transistor, and if the audio signal was to get on the DC distribution bus, it could go to the previous stage and end up going into the input of that stage, and then we end up with a feedback path, and that can create noise and whistling and screeching and all sorts of nasty things that we don't want to have happen. So the important part of any electronic project is to have a nice clean DC distribution bus, where the 9 volts that we hook up our power leads to ensures the 9 volts will stay clean. I will also mention that it is generally good engineering practice to have your DC voltage input on the last stage of what it is that you're building. If it's the last stage, or say the output stage, such that your first stage or your low-level signal stage will be the furthest away from where you feed your voltage in. That way it has maximum isolation by virtue of the decoupling networks. Well, we're about out of time with part 1. We have our circuit board completed now, so coming up in part 2, I'm going to show you how to modularize your active components, your transistors and your integrated circuits, in a manner that'll make it easier for you to incorporate them into your circuit design. Thank you for watching this episode of Tronics in 10. My name is Brian. Until next time, bye-bye.